All right, everyone, today we might have lured you here under false pretenses, I'm not sure, but hopefully those of us who are under 50 might live forever, even those that are slightly above or right at the limit. But guys, why are you joining us here today?
Okay, well, I guess I've been working on what you might call emerging tech for about 15 years now. Started off interested in Earth observation, space tech. After a while, realized that maybe it'd be more interesting to look at the brain. Moved over to applied science, applied neuroscience. In that area then we got working on brain-computer interfaces after a while, started digging into that, thinking about what we can extract from the brain. And then we realized, well, this could work in the other direction, so we started working on brain stimulation and sending signals in, so this kind of bi-directional interaction with the brain. From that work, I kind of got involved with the European Commission and ended up in their kind of coordination actions, they're called, where you kind of bring all of the research in Europe together and kind of see who's doing what, get them together to exchange ideas. And we did one of these on something called human-computer confluence, which was something we invented at the time. I don't even remember why we called it that, but it was trying to get at the idea of brain-computer interface, human-computer interface, and what happens when the interface disappears, when you somehow meld with the technology. And this could be thinking about things like implants, or it could simply be something that's so well designed you don't see the interface. So that's kind of my interest in these topics. And Alex asked if I'd be interested in this, and I was as intrigued by the title, I think, as some of you are. I'm not sure I would agree with it.
We'll talk about that later. All right, Ben?
Yeah, so I did a PhD in Trinity College Dublin, and then a book which came out last year. And it was about the influence of fiction and various kinds of science fiction on the field of transhumanism, which is the idea that we're going to become more than human through technology and possibly merge with technology to become other kinds of beings. And so my first book came out last year, and I'm working on another book at the moment with Zoltan Istvan. Some of you may have heard of. He ran for president in 2016 as the founder and head of the Transhumanist Party, and he kind of labelled himself as the science candidate. So it's a field I have a lot of interest in, and I think there are a lot of fascinating possibilities.
All right, so sorry, and I am just an overall nerd, and I want to live forever, and I try everything that I can on myself. That's about it. But so what is transhumanism, and kind of what are we here to talk about today? I'm going to ask a bunch of questions, maybe tell you guys really quickly about what's going on in the world, and then we're just going to jump into a conversation with these awesome experts. But transhumanism, in any case, is just the idea of what can we do for the human species to be able to transcend itself, to become something more than human, to be able to be more intelligent, to be able to live longer, to be able to eliminate disease, and all these things, right? And a lot of the questions that come up a lot of times is the human brain limited? Is it limited like as a factory default? Is there something that we can do to enhance this? We're also talking a lot about, life extension. There's some really cool examples, like Aubrey de Grey from the Sense Research Foundation has been able to extend the life of mice 3 times. So that's about 300 years in human years. And these mice are super happy. They're like having sex and everything is great, right? And there's all these amazing things that are going on, and we have CRISPR-Cas9 technology, which is allowing us to edit genes, and you can eliminate things like cancer and muscular dystrophy and multiple sclerosis and all these things. And contrary to popular belief, yes, you could make somebody more intelligent, or you could change their eye color. But to quote a friend of mine, when you have to do this gene editing, changing somebody's eye color is, if changing somebody's cancer status is 1 page of 1 book in the genetic sequence, changing somebody's eye color is like an entire chapter. So it's complicated for if anybody's always wondering these types of things. But there's a lot of other things happening in the world of transhumanism. And we have companies that are trying to help us regain or enhance our senses. So there's a really cool company that's created something called NorthSense. I don't know if anybody's heard of this, but it's a chip that goes implanted on the wearer's chest. and it vibrates or it sends a signal whenever that person is facing true north. Now, I don't fully understand why somebody would do this, but I think in any case it's cool, because what they're saying is that they're enhancing the human's ability to comprehend or feel other feelings. So the more senses we have, the more experiences that we can also have throughout our life. So that's kind of cool. And I mean, I don't know how far you can go, and like, I don't know if I would want to have like a Wi-Fi sensor that like gives me a tingle on the back of my neck when I know there's open Wi-Fi at an airport or something like this. But maybe, nevertheless, it would be really useful. Cryonics, I don't know if anybody's heard of this, but this is absolutely crazy and very cool. There's a bunch of companies around the world that are willing to freeze you. I think you've probably heard of this. One of the biggest ones is Alcor. So for the small sum of $200,000, they will freeze your body in the hopes that in 3, 5, 10, 20, 50 years, they'll be able to thaw you out and cure you of whatever disease you want. But don't worry, because for those budget-minded people here, you can also just freeze your head for $80,000, which obviously seems like a much better option. They chop your head off and then they freeze your brain, assuming that in 50, 60 years, they'll be able to grow or regrow your entire body in some ridiculously awesome genetic manufacturing way. So then the question arises that as we become more transhuman, as we apply more things onto our bodies, how much of our humanity is left, or how much of our consciousness is left? And there's people around the world that are talking about this idea of whole brain emulation, right? You've heard about this. It's downloading our brain onto a computer. There's a bunch of people around the world that believe this is possible. Ray Kurzweil is one of the biggest ones. And when he dies, he wants to be able to download his brain onto something else, right? So how do we put a brain in silico, they call it? What's more, he has all these recordings of his father in his garage and videos of him and all these things. And he wants to be able to take all of this information and put it on a computer brain to see if he can reproduce the essence of his father. This is obviously something, again, that's very much up for debate. Anyway, there's a bunch of really cool things within this world, right? There's human body modifications. We just put a chip implant in somebody the other day. Somebody has a chip implant that can sense seismic activity around the planet. The options are incredible. There's a company called Kernel, which is making a brain implant that's able to hopefully in the future extend our memory capabilities and all these ridiculous things. But not only do I have to undergo ridiculous surgery, there's things that in the world of transhumanism people are doing right now, like going on special ketogenic diets, reducing their sugar intake to lower the amount of cancer, or they're going into intermittent fasting. By going into intermittent fasting, they're creating cell apoptosis, so the death of cancer cells, and all these ridiculous, awesome things. So in the end, not only can we modify our body and try to live longer and eliminate cancer in hopefully the next 10, 20, 30, 40 years, we can also become more intelligent. Companies and people like Stephen knows are using transcranial direct stimulation, electrodes on the brain that are able to stimulate neural activity in certain areas to make us more proficient at tasks, enhance our neuroplasticity, which is our ability to learn faster, learn new skills, and all these crazy things. So this was just a little swipe through what transhumanism is. Obviously, there's a bunch of questions to be asked, and this is why I have these two wonderful people here. Guys, out of everything that I just blasted through, is there anything that you want to get into?
Well, I always think about this from the point of view of applied neuroscience, because it's the world I know. I've met Ray Kurzweil briefly, and I know the way he thinks about it, and he thinks about it as a computer scientist, basically. That if we have enough computing power, we'll be able to simulate the brain. And I think we're so far from understanding how the brain works that this is just wrong at the moment. I think it's probably inevitable that we will do it, but I think all of the efforts right now are kind of misplaced. We discovered a new type of neuron last year that we didn't know existed, the rose-hip neuron. We don't know really what its role is in terms of how the brain works. We have no clue how consciousness is generated. The company I used to work for, Neuroelectrics, which actually I don't work for anymore, I should update that. they have a project running on measuring consciousness. But here it's like just measuring the level of consciousness. Are you asleep? Are you awake? Are you in coma? So we're kind of at that level of just getting an idea of how conscious you are. No idea what consciousness means. It's still a philosophical question. And then we were working on, stimulating the brain, injecting currents. We could do things that were kind of clinically interesting with this technology, and there's some really amazing things coming down the pipeline in that direction. But when we started to model the brain and then inject currents and see how they interact, from the model you can see that we just don't know how this stuff works on a very, very fundamental level. We have this idea that the neurons are kind of like transistors and that they're interacting and they're on and off and there's information being sent around. All of the models ignore the electric field interaction between those neurons, completely ignore it. They ignore the glial cells, they ignore the hippocampus, they ignore everything to simplify the model. And that maybe you can run in software, but it's just so far from kind of a realistic simulation of the brain that I think people like Ray are overly optimistic, to put it mildly. I think Ray will be long dead before that's ready, no matter how many pills he takes.
So in the sense of, so I'm a physicist and we always talk about how space, we only know, say, 10%, right? And I always wonder, how do we even know that, because it's kind of infinite. So when it comes to the brain, do we know how much we know? If it's a loading bar of knowledge of how much of the brain we've been able to understand, are we anywhere specifically, or is it just an unknown question?
Well, we're further along than we were 20 years ago. There's been like a huge amount of progress. But the fact that we discovered a new neuron just last year, to me, says everything. It's like we don't even fully understand the components, what's in there. And then there's like other bigger questions as to computationally how well that works. There's a European funded project which is now talking about the brain working in, I think, 11 dimensions mathematically in terms of information processing. So it's not even just a simple computing system in that sense, like in terms of the graph and all of that, how the network works. It's just, there's so many levels of unknowns. If I were to guess, I would say we're at like 1% of what we need to know.
So to get down to the question that everybody wants to hear is, how close do you think we are to, say, being able to wear a hat or implant a chip that on any given command will help us learn something better, do better on a math test, remember names better, or run faster, and something like this?
That I think is a lot closer when you look at some concrete problems. I know a guy called Roy Cohen-Kadosh in Oxford is working on using brain stimulation basically to enhance mathematical ability of people with dyscalculia. So they have a deficit, a bit like dyslexia for numbers. For people like that, you can increase their mathematical abilities through brain stimulation in a fairly coarse way. He's done a lot of interesting research on this, and that's just kind of the tip of the iceberg. I think there's a lot of possibilities there. But you have to bear in mind the brain is already doing things, so if you enhance one feature, you kind of have to take that computing power from somewhere else. And an interesting way to think about it, to learn Braille, you need to be blind because you're using your visual cortex. It's very, very difficult to learn Braille if you're not blind, because that visual cortex has already been used all the time. So to repurpose it, you can learn Braille a little bit, but to really become proficient, if you're not blind, there's no computing power available for the task. So even though people talk about the brain being infinitely expandable, it's actually all being used all the time for something. We're not sure how it all works, but it's being used somehow. I think a lot of this stuff will actually sit in the technology for a long time, so we'll be able to enhance, but we'll be translating that into something we can already understand and using our existing senses somehow.
Great, thank you. Ben, where do you want to jump off from?
Well, one thing you mentioned is cryonics, which in many ways I think epitomizes the essence of what transhumanism is, this idea that we might one day be able to live forever or come back from the dead. But I guess for a lot of people, cryonics won't catch on until they actually bring somebody back from the dead, and then everybody will want to do it. You mentioned Alcor, which was founded by Max Moore, who was actually one of the guys heavily involved in defining the philosophy of transhumanism early on. And he kind of defined it being a transhuman is being in a transitional state between human and what comes after, which is maybe truly post-human beings, where we are more than organic, where we're part technical, part organic, or whatever. So I think some of the far out there stuff is fascinating, but it is very far out there. One of the other things that comes under the rubric of transhumanism, which I think is incredible just as an idea, is that maybe at some point far in the future, through quantum computing, there's this field called quantum archaeology, where literally, if we know enough about how to construct and reconstruct the universe, we might be able to reconstruct particular points in time, particular human beings and their memories, and literally recreate people. So if you're under 50, you might be living forever, maybe. But we won't just be stuck with the current generation. We could literally bring everybody who's ever lived back to life. And what does that mean for where we have to live? Certainly one Earth won't be enough.
That brings us to a lot of different questions. Like transhumanism is also talking about being able to go and live on other planets, right? Like how do we prolong this species? But maybe that's a conversation for another day. I see that you started talking about this now, but the question is, the title of this presentation, if you're under 50, you're going to live forever. Agree, disagree? Where do we want to go from this? What do we think? What's the holistic view on this?
I think a better question might be, has the first person who's going to live forever been born, rather than everybody under 50 is going to live forever. If you're Jeff Bezos, maybe you could be that person if you put all your resources towards that. And there's kind of one caveat that we have no clue how the brain works now, but if we do invent artificial general intelligence, it might figure out everything we need to know about the brain to do this within the next 30 years. That could still happen. So it's not a never, but I doubt it will be available to all of us when it's first launched.
So I read somewhere that Ray Kurzweil spends about $2,000 a day on supplements that he takes absolutely every single day. So maybe this is not something that's accessible to all of us. But I'm really interested in maybe understanding the trend line of transhumanism in the last, I don't know how long it's been. And Ben, I know you wrote a book about this and you kind of understand the history. Maybe understanding the steps that we've made for the last X years, we can understand where we're going to be.
Sure, so I suppose one thing that I would just point out is that transhumanism is not just a set of technologies about human enhancement, it's also a specific set of ideas and philosophies, which was defined mostly in the 80s and 90s by people like Max Moore. The term actually dates back a lot further. Aldous Huxley's brother, Julian Huxley, he used the term in his book Religion Without Revelation in 1927, and he talked about the human species being able to transcend itself and overcome itself, maybe collectively, and he thought that humanism wouldn't be a good enough term for this, and so he talked about transhumanism, the trans obviously relating to transcendence and transition. So the history in terms of philosophically how it was defined, we're talking about the 1980s and 90s. There were various groups in and around Silicon Valley. One of the first was the Extropy Institute, founded by Max Moore and Tom Morrow, and that developed a kind of a set of ideas around the notion of boundless expansion. Extropy was a word that they came up with, which basically meant the opposite of entropy. So if entropy is decay, then extropy is boundless expansion. And that idea has been integral to transhumanism. So we're not just talking about ideas and technology, but also personal philosophy and how you orient yourself towards the future. Are you someone who's willing to embrace the new technologies as they come along and get a chip in your brain and so on? And that kind of makes you a transhuman. In terms of the science,
So,
Stephen.
Thank you. So you mentioned something like this, and I'm a giant science fiction nerd, and as we were mentioning before, I read William Gibson's Neuromancer, and he predicts a bunch of different things from like cyber hacking to implants and all these kind of things, but it was written in 1984 or 82, way before this happened. And so one of the things that I wanted to talk about is when we're always talking about the human of the future and cyborgs and all this kind of stuff is going on, one of the questions that we were, the three of us, thinking is, when we're creating this new technology and we're evolving into the future, we've read all these things in books, we've seen all these things in movies. How influent is science fiction in the technology that we're creating in the world of transhumanism and how we're hoping our kind of, species to live on?
I've been reading Ian M. Banks my whole life, so everything I've done has kind of been coloured by his particular vision of utopia in the future of the culture. So I often think about it that way, and I think it's an optimistic goal to aim for something like that. You'd be inspired by that, but on a really practical level, when we did this human-computer confluence thing, we kind of surveyed all of the research projects going on in Europe around these themes, and I think 8 of 10 had been inspired directly by a sci-fi book or a movie. As in the initial idea for the research came from sci-fi directly, and they said, it'd be cool if we could do that. And then 10 years later, they got a research project funded to start working on it. And those projects are still running. I think 3 of those are actually based in Barcelona, which is interesting. There seems to be a little hub around that stuff here, but 8 of 10 of these big projects were directly inspired by sci-fi. So I think whether whether the people who are funding this realize it or not, sci-fi is directly driving at the kind of research that is being done, at least in Europe, and I'm sure in the US it's similar.
You mentioned Neuromancer, which came out in 1984, William Gibson's book, and of course that was the first use of the term cyberspace, which has become so ubiquitous. So I think science fiction definitely influences not just creators, but people day to day, like this various studies suggesting that the flip phone became a lot more acceptable because of the communicator in Star Trek, because people had already kind of seen it and it was something that they wanted to have, and then it became available. I would say one of the big bugbears among a lot of transhumanists is that there aren't more major mainstream science fiction texts which are encouraging of the idea of science. A lot of the archetypes from science fiction are negative in terms of where technology will lead us. If you think about what's often considered the first science fiction text, that's Frankenstein from 1818, Mary Shelley's work. I mean, it's basically about a guy who creates an artificial life form that then seeks to destroy him. And that archetype has been updated through the centuries since. Terminator's just basically a modern version of Frankenstein. So I think there are a lot of negative dystopian science fiction texts out there which negatively impact the public in terms of how they approach scientific developments. So it's not just positive developments, but also a lot of fear that's kind of created through science fiction.
So let's mitigate a little bit of that and let's get real for a second and into the world of positive. What is some of the cool stuff that you guys know of that's happening right now that these people would like to hear about?
Well, I think I mentioned some of them already. So there's a lot of really interesting things going on around brain stimulation. So I'm not talking about big medical equipment, wearable caps that can selectively stimulate parts of your brain while reading the activity of the brain. So you have this kind of possibility of closed loop systems. You're still wearing a big cap, but we're kind of at the point where you can have something that you could be wearing right now, sitting in the audience that's in real time interacting with your brain. And so as I said, there are things around enhancement that you could do if the technology kind of interacts with your brain rather than on a biological level. I think that's very cool. Some of the new stuff we're working on now is around digital therapeutics. And a lot of that's about understanding, I'm not sure how to put this, but we have a lot of cognitive biases and a lot of impediments to kind of making good decisions for ourselves. A lot of evolutionary mistakes, maybe. So we evolved in a certain way. We're not perfectly adapted to the world we live in now. Maybe we were never perfectly adapted to the world. And maybe we can, using technology, help ourselves overcome some of those things. So we're working on cognitive behavior therapy and things like that, with a lot of clinical applications, and using simple technology like your phone to understand what you're doing and then help you make better decisions based on what we know about the mistakes we typically make. We make a lot of mistakes all the time. Like, we have so many biases, I've lost count of them. I think that's kind of an interesting direction to use technology to help us overcome these things and kind of basically watch out for our blind spots and let us know when we're in them. I think that kind of technology used in in concert with psychology is kind of an interesting new angle as well.
Definitely like that point of view, and I might need it. Ben, something cool
Sure.
that we look forward to that's happening right now?
I suppose for me, for personal reasons, what you mentioned around genetics and genetic editing is so important. So I have a rare genetic disorder called Fanconi anemia. And so my life expectancy is actually a lot lower than 50. It's kind of mid-30s. So the possibility that emerges through genetic technologies to extend life, I think, is so important. And there's been so much development in that regard. When I wrote my book about having Fanconi anemia 10 years ago, the average life expectancy was 22. And a couple of years ago, for the first time in history, there were more adults with the disease than children because the life expectancy was being extended. And that's all through what we've learned through genetics and, you know, improved transplants and stem cell transplants and so on. So I think we can all look forward, hopefully, to longer lifespans, even if we can't live forever.
For sure. So, we have 30 seconds left. So the question is, because we could keep talking forever, if you all had the chance of, at the last year of your life, freezing yourself, and then there was a 1% chance that you'll wake up in 200 years, by a raise of hands, who would do it? Okay? So like, 15% of the people that are here, 16, 17%, hands are going down. All right. Well, did you guys raise your hands?
We did.
I'll see you in 200 years, and whoever said it. Thanks so much, everyone, and thanks for listening.
Thank you so much. That was genuinely fascinating. I expected nothing.